Cool.
Yes,
Welcome,
sir.
Professor Swati, sir.
Yes,
Welcome.
okay, sir. Starting the
Uh, Swati sir had joined us. So kindly initiate.
Yeah, that's all I have joined. Thank you.
Thank you, sir. Thank you.
A very pleasant afternoon to one and all present here. My name is Mukul Singh, PhD research scholar at Department of Electrical Engineering, School of Engineering, Gautam Buddha University. Thank you to each and every one of you for being here with us today. It is my great pleasure to welcome you all to our online 1 week short term course on the topic Emerging Trends in Power and Energy Systems STC ETPES 2020 to be organized from 24th of August to 28th of August. The event is organized by Electric Power and Protection Club and Techno Design Electronic Circuits Club, Department of Electrical Engineering, School of Engineering, Gautam Buddha University. The conveners of the event are Dr. M. A. Ansari, Research Coordinator, and Dr. Omvir Singh, EPPC Coordinator, School of Engineering, Gautam Buddha University. Today, in our session 1, we have Dr. Prabhakar Tiwari, sir, for the topic Role of Energy Efficiency and Conservation. Dr. Prabhakar Tiwari is an associate professor at Electrical Engineering Department, Madan Mohan Malviya University of Technology, Gorakhpur. He has completed his BTech from Madhaban Malviya Engineering College and his MTech from Energy Center, IIT Delhi. He has completed his PhD from Jamia Millia Islamia, New Delhi. He has research publication of more than 52 publications in international journals and reputed international conferences. He is IEEE Executive Committee member and he has a teaching experience of more than 18 years. He has been awarded a fellowship of Outstanding Volunteer Award IEEE UO section. We are very pleased to invite Dr. Prabhakar Tiwari to give us his valuable information and knowledge and provide us a valuable lecture on the topic of role of energy efficiency and conservation. We welcome you, sir.
Thank you very much. Thanks a lot. Very good afternoon to everyone. Hello. Hello.
Yeah, good afternoon, sir.
Yes, sir.
Hello. Yeah. Good afternoon. Can you see me? Hello.
Yes, sir, your screen is visible.
Can you see my screen? Hello.
सर ये सर थोड़ा सा ना हॉरिजॉन्टल कर लीजिए फोन को आप थोड़ा सा.
Thank you. Thank you very much. अच्छा, एक मिनट. अब ठीक है?
Yes,
Yes,
sir.
sir. ठीक है सर ठीक.
हेलो. हाँ, तब अब ठीक आ रहा है?
हाँ, इट्स ओके सर.
Okay. So very good afternoon, everyone. My topic is role of energy efficiency and conservation. Energy is a very important in everybody's life. We know that the economies are measured by the capacity of energy capacity of the country. It is not a very new trend. It's very old and very important measure. Now the question is, what is energy? Energy can be defined as the capacity or power to do work, such as capacity to move an object of a given mass by the application of force. Energy can exist in variety of forms such as electrical, mechanical, chemical, thermal, or nuclear, and can be transferred from one form to another. Now, what is the significance of energy? As I told you, that energy is the most important parameter to measure the prosperity of a nation. The positive impacts of energy usage are the better industrial development, better commercial development, better agriculture productivity, better social development, and comfortable lifestyle. Can we stop using energy? Answer is big no. We cannot stop using the energy, but yes, we can conserve it. We may use it efficiently. We may convert it to a form that is the best to use. And we know that electricity is the best one from this perspective. Now, question is, why energy conservation? The answer is, energy conservation will save the money and energy and thereby resulting in protection of the environment. By obtaining necessary knowledge and information on the main operating principles of the devices or appliances that are in common use and information on which to make the right decision in selecting the most energy efficient and economical choice. We know that Bureau of Energy Efficiency is playing a vital role to ensure energy efficiency and conservation in our country, and they have done a lot. For details, more details, you can visit its website. What are environmental issues? Because energy use, as I pointed out, it is not free from the negative aspects. It raises so many issues. The issues, few of them may be enlisted as effect of fossil fuel production, effect of fossil fuel combustion, greenhouse effect and global warming, ozone layer depletion and destruction, acid rain, radiation and health, change of ecology due to waste energy disposal and air pollution. The next question is, what are the factors of energy conservation and energy efficiency? You know, energy efficiency is a means of energy conservation. It is a part, you can say, we can by efficiently using the energy, we can conserve it. But conservation is not limited to efficiency only. There are so many ways to ensure the conservation of the energy. Like green buildings, it saves a lot of energy throughout its lifetime. Energy efficient commercial buildings, energy efficient appliances, energy saving resources like renewable energy, better operation that can be again categorized as reduction in the losses and flattening load curve or reducing the peak demand. Now the next question is how to conserve energy at home. Energy conservation is very big topic, very vital. We need to discuss, we need to focus on some area, and that is here I have taken a small unit, that is our home. At home, we have lighting systems in every home, maybe smaller or bigger, maybe single person or a very big family is there, but lighting systems are definitely there and they are large in number. So one of the best energy saving devices is the light switch. Turn off light when not required. Many automatic devices can help in saving energy use. In lighting, consider implying infrared sensors, motion sensors, automatic timers, dimmers, and solar cell wherever applicable to switch on or off the lighting systems. You know that we can either use the automatic sensors or simply even in manual ways also by switching off and on manually, we can save a lot of energy. We all are from educational institutions. We know that many times, especially when we go to classrooms at 4 or 5 p.m., and sometimes we find that even there was no class after lunch, but all the appliances are just running without anybody there in this field, this area, just by not only just by manual or more technical ways are there, and people have developed so many devices. As far as possible, use the task lighting. Another way, task lighting, like table lamp, which features light, which focuses light where it's needed. Like a reading lamp, for example, lights only reading material or reading area other than the whole room. Another is dirty tube lights and bulbs reflect less light and can absorb 50% of the light. So what to do? Dust your tube lights and lamps regularly. Fluorescent lights and CFLs that convert electricity to visible light up to 5 times more efficiently than ordinary bulbs, and thus save about 70% of electricity for the same lighting demand. 90% of the energy consumed by an ordinary bulb is given off as heat rather than the visible light, even sometimes more than 90%. So, replace your electricity guzzling ordinary bulbs with more efficient type. And that is, what are those? Like LED bulbs, because these incandescent lamps that use 10 to 12 points more electricity than LEDs. And that is, I'm talking about normal LEDs. Even very efficient LEDs are, though they are very costly in India, but yes, it is there, which saves more than 95% energy as compared to the normal cold bulbs. Again, ICL that generates approximately 10 lumens per watt, whereas LED generate up to 120 lumens per watt. That is again for ordinary LED bulbs. This comparison. Another is, let's take room air conditioner. Use ceiling or table fans as first line of defense against summer heat. Ceiling fans, for instance, cost about 30 paise per hour to operate, much less than air conditioners. That costs rupees 10 per hour. You can reduce air conditioning energy use by as much as 40% by shading your home's windows and walls. Plant trees and shrubs to keep the day's hottest sun off your home. One will use 3 to 5% less energy for each degree air conditioner is set above 22 degrees. So set your thermostat room temperature, that is at, let's say, 45 degrees, and that will provide you the most comfortable and most suitable temperature to you. Using ceiling or room fans allows you to set the thermostat higher because the air movement will cool the room. A good air conditioner will cool and dehumidify a room in about 30 minutes. So use a timer. Timer plays very vital role again to leave the units off for some time. Keep the doors to air conditioned rooms closed as often as possible. Especially at home, we find even adults, not only children, they don't care when a room is very chilled and they open the door. It costs a lot of units to again bring your room at same temperature. Next is clean the air conditioner filter every month. A dirty air filter reduces airflow and that may damage the unit. That reduces this amount of cooling also. Clean air filters enable the unit to cool down quickly and use less energy. If room air conditioner is older and need repair, it's likely to be very inefficient. It may work out cheaper on life cycle cooling to buy a new energy efficient air conditioner. And better is to take the highest rated air conditioner available in the market, because during the whole life cycle, it will save much more energy. It will save much of your money as compared to the additional amount paid by you. This is for refrigerators. Make sure that refrigerator is kept away from all the sources of heat, including direct sunlight, radiators and appliances such as even oven and cooking range. When it is dark, place a lit flash inside the refrigerator close to the door. If light is around the door is seen, then I think there is some problem in the ceiling and then you should replace the ceiling. Refrigerator motors and compressors generate heat, so allow enough space for continuous airflow around the refrigerator. If the heat cannot escape, the refrigerator cooling system will work harder and use more energy. Next is a full refrigerator is a fine thing, but be sure to allow adequate air circulation inside. Think about what you need before opening the refrigerator door. Normally, what happens, people go to the refrigerator, first they open the door and then decide what to do. That is a very wrong practice. What happens? Whole amount of chilled air that comes out. And again, it needs a lot of energy to recool to the same temperature. So you will reduce, if you first decide that what you need to take out, then when you open, you will just pick your desired thing and then close the door. You will reduce by this way a lot of energy by quickly closing the door. Allow hot and warm foods to cool and cover them well before putting them in the refrigerator. Refrigerator will use less energy and condensation will reduce. That is again a very bad habit. Few of us, what we do, few, especially ladies, understand that if something, now even if you have to make, ice cream, then first what to do? Everything should be cool to the room temperature, including the milk, and then put it into the refrigerator so that energy consumption will be least, right? Then make sure that refrigerator rubber door seals are clean and tight. They should hold a slip of paper snugly. If paper slips out easily, replace the door seals. That happens many a times, especially after some time. This problem occurs, and then you should keep on checking. When dust builds up on the refrigerators, condenser coils, the motor works harder and use more electricity. More electricity. Clean the coils regularly to keep sure that air can circulate freely. For manual defrost refrigerators, accumulation of ice reduces. Now I think defrosting is very automatic. Even frost-free refrigerators are available. So accumulation of ice reduces the cooling power, and sometimes it blocks the duct also. By acting as unwanted insulation, defrost features compartment regularly for the manual defrost features. Then tips for water heater. Water heater is very important, especially in winter days, because even not only small guys, even for everyone, it is wise to keep the temperature optimal before taking bath. So very chilled water or very warm water, both should be avoided, because both of them, they create different type of health problems. So to help reduce the heat loss, always insulate hot water pipes, especially when they run through unheated area. Never insulate plastic pipes. By reducing the temperature setting of the water heater from 60 to 50 degrees, one could save over 18% of the energy used at the higher setting. It is one aspect. And see, from the same point, there is another aspect. Sometimes these pipes are fitted at a very good height, and then water comes out from the pipe, and I think 3 to 4 feet, and then before it is poured to this tub. So what happens? It is cooled in between them. So it is better to use some additional pipe, maybe temporary pipe, so that this cooling of the water is avoided, so that you will save a lot of energy in this way. And last one is switch off the water heater if it is automatic type. It takes a lot of energy, so better you switch it off, right? Then microwave oven and electric kettles. Microwave saves lot of energy by reducing cooking time. In fact, one can save up to 50% on your cooking energy cost by using microwave oven instead of regular oven, especially for a small quantity of food. But remember that microwaves cook food from outside as towards the center of the dish. So if you are cooking more than one item, place larger and thicker items on the outside to cook better with least energy. Then next is use an electric kettle to heat water. It is more energy efficient than using an electric cooktop element. When buying a new electric kettle, choose one that has automatic shut off button and a heat resistant handle. It serves a lot of purpose. It takes more energy to heat a dirty kettle. Regularly clean your electric kettle by combining boiling water and vinegar to remove the mineral deposits. Don't overfill the kettle for just one drink. Heat only the amount of water that you need. That is another way. Sometimes you need very small amount of water, but you completely fill the kettle. And what happens? The energy is wasted. The water is wasted. Then again it is cool, and then somebody when she needs, after some time again it is cool. So taking the amount of water only that is needed to be drink, you can save the energy. Next is our computers. Turn off your home office equipment when not in use. Many times we leave our computer without switching it off. A computer that runs 24 hours a day, for instance, uses more power than an energy efficient refrigerator. And we know in computer, even sleep mode is there. Sleep mode is there. So instead of leaving it, if you need quickly to start, we can put it in sleep mode rather than leaving it to waste the energy. If a computer must be left on, turn off the monitor, because monitor uses the most energy. This device alone uses more than half of the system energy. So never leave your computer without turning off your screen at least. Setting computer monitor and copiers to use sleep mode when not in use helps cut the energy cost by approximately 40%. And what happens? Very important factor. What happens normally, our photocopiers, they are kept connected. So when moving out of the office in the evening, what we can do to save the energy, we can switch off our computer, and if not going for a very long time, then switch it off from the switchboard. Otherwise, UPS may be switched on, UPS input, so that your battery keep on charging. If it is you are going for a long time, going out for a long time, but otherwise switch it off, so that otherwise even when you switch off your computer, your copier will take the energy. It will be switched on 24 hours, and then it will keep on consuming some energy. Battery chargers such as those for laptops, cell phones, and digital cameras draw more power when they are plugged in and are very inefficient. So when not in use, pull and plug. Pull the plug and save the energy. This is another very important, and sometimes our bad habit. What we do, we just take the mobile and leave the charger plugged into the socket, and then it keeps on taking some energy. Better to pull it out when not in use. Screensaver save the computer screen, not energy. Startups and shutdowns do not use any extra energy, nor are they hard on your computer components. Very important factor. Many times we don't know, but we think that like our vehicle is starting takes extra energy. One may think, but it is not so. So better what to do when you go out, switch off your computer. Because when a screensaver is active, your screen energy will not be used, but your processor will keep on taking the energy. So better to switch it off when it is not needed. In fact, shutting computers down when you are finished using them actually reduces system wear and saves a lot of energy. Tips are fine. Replace the conventional regulators with electronic regulators for the ceiling fans. Install exhaust fans at higher elevation than ceiling fans. Because ceiling fans, ceiling fans, they give you cool air. And the air having most temperature is at the top in the ceiling area. So better what to do? The exhaust fan should be kept close to the top floor, so that the air which goes out that has the maximum temperature. So you will not need the extra cooling. In the fans, energy efficient fans. This is the tip actually. Apart from that, as an electrical engineer, electrical graduate, postgraduate, we know what are the factors here. Good quality, not only in fan, in every appliance. First is energy efficiency. First term, please see the topic, energy efficiency and conservation. First, to ensure energy efficiency. And how energy efficiency will be ensured? First, your appliances that you buy when you are at the shop, when you are shopping even online, first you have to ensure that your appliances that you are buying is of good quality. And good quality appliances will not only will have longer life, but also it will be very energy efficient. and it throughout its lifespan it will save the energy. So energy efficient instrument is the first one that you should ensure. Even in science, if we are talking about, don't buy single bearing fans. Always buy double bearing fans. Good quality, star rated instruments. And we know that Bureau of Energy Efficiency, they rate the instrument from single star to 5 star. 5 star rating is maximum, right? So always buy wherever possible, highest star rated instrument appliances should be bought, so that least energy it will consume. Then electric iron, you know, there was, 20 years back, I remember 25 years back, having an automatic electric iron, it was very costly affair because, sensors were not so much developed, and having automatic switching electric iron, it was very costly. Nowadays you can see what is the cost of, very cheaper. And you will not find even non-switching type, automatic type electric irons. So select iron boxes with automatic temperature cutoff. That is the very important aspect. And it is not only important, see, automatic temperature cutoff iron, it is not only important from the energy saving point of view. Here more than is the safety point of view. When temperature of the surface becomes very high, it keeps on increasing. And when you use it at the cloth, it is burnt. It destroys the fabric. So automatic temperature cutoff, electric iron should be used. Use appropriate regulator positions for the ironing. Again, there are regulators are there. So don't keep very hard. Yes, depending on the type of cloth, we need to select the position of the regulator. Then don't use more water on the clothes while ironing, because it will take a lot of energy. And never iron wet clothes. It will take the highest amount of energy. Oh, sorry. Yeah. Then here is an example of energy efficiency. As I have been talking about the energy efficiency, my highest emphasis is on the energy efficiency, because it is, it gives a lot of opportunity for the electrical engineers to design good quality appliances, to show their talent. Conservation comes next after the efficiency. So let us take the example here of energy efficiency. Like, there are 3 examples: LED, CFL, and incandescent bulbs. That is the conventional bulb, Thomas Alva Edison bulb, the very yellow light bulb. We all know it. But yes, nowadays we are talking about LEDs, and we say it is very superior. But there was a time when polished it was Now, whole police state in US that was lightened first time, then you can imagine it was a very big event, and from there, after long process of the change of the material, improvement in the you know same material, because that time first time tungsten was not used. So with the change in the improvement in the quality, now we have came up to LEDs, and normally here the example we have taken is normal LED bulbs. Even more efficient, electrically efficient LEDs are available in the market nowadays. But here simple LED we are talking about that is available in the market. First parameter is projected lifespan. In LEDs, more than 30,000. It is the example that was given on Bureau of Energy Efficiency I have taken. But even if you see, go to GEM portal, you'll find LEDs are available with guarantee of 5 years. And if you calculate 5 years, convert into hours, then it will be more than 40,000 hours. So LEDs normally have 30,000, CFL let us say 6,000 hours of lifespan, and normal bulb 1,000 hours. Wattage per bulb, let's say 9 watt, 12 watt, and 60 watts. Then cost per bulb 200. That is again old data. Nowadays 9 watt CFL, that is hardly 60-70 rupees, 70 to 80 rupees it cost. Then CFL, I think it is phased out 120, and then normal bulb 15 rupees. Kilowatts of electricity used over 30,000 hours in units. That is, LED uses 270 units, CFL 360, and normal bulb 1800 units of electricity. Lifetime cost of electricity, that is 1,350 rupees for simple for LEDs, CFL 1,800, and normal bulb 9,000 rupees. Bulb needed for the 30,000 hours. If it is needed to write in 30,000 hours, then LED single LED is needed, whereas CFL 5 and normal bulb 30 bulbs are needed. So if we calculate the cost of the bulb even, then 200, 600, and 450 normally. See how much it is. And so the total cost for 30,000 hours. In LED, total cost is 1,550 rupees, whereas in normal bulb, it is almost 10,000 rupees. So energy efficiency, if you still believe that energy efficiency is costly affair, answer is no, big no. It is very cheaper. You have to just calculate, you have to do the holistic calculation. So energy conservation, here are few quotes that I like the most. That is, save energy. How would you like it if someone turned you on and then left? That is for those who don't care. I always I always tell my students that use the energy very efficiently. Save the energy, conserve energy. And you know why? Why to conserve energy? Why conservation is very important? Because see, there are two conditions. One is you can you can buy 1 unit of energy and give to someone, and other one you can save the 1 unit of energy. Means when you save 1 unit of energy, that is more important. Why it is more important? Because when you save 1 unit of energy, you save more than 2 units of energy generated at the substation. And when you save this 2 units of energy, finally, then you don't save only that 2 units of electricity, 2 units that you if you are getting it at, let us say, 5 rupees per minute or 10 rupees even, then you don't save only 20 rupees. You save so many things. If you see the supply chain of the electricity, then you save when 1 unit for generation of 2 units of electricity, when coal is burnt, then you convert it into the efficiency. How much our power plants, they have the efficiency less than 20%. Actually, best power plants, that is, I'm talking about NTPC power plants, maybe claimed efficiency maybe 22%. Actual operating efficiency, because they are not operated in the best efficiency conditions. So whereas the claimed efficiency measured is the best one. So where the remaining amount, let us say 20% is converted to energy, to electrical energy, where remaining amount goes? It goes as a waste, as a heat to the environment. So it will cause the raising of the temperature. Temperature will be increased. Temperature, it will cause rise in the temperature and global warming will up. That is one aspect. Another is large amount of flue gases, large amount of toxic gases that is produced when coal is burnt. SOx, NOx, carbon monoxide, lot of carbon dioxide, lot of toxic gases. And then oxygen, huge amount of oxygen. To burn the coal, it is consumed by the plant. And you know, oxygen, how important it is for the human being and any creature. It takes the oxygen, huge amount. And then what else? It takes huge amount of water. Because that is to convert it to run the turbine. What is the cycle? Water is heated, and then it is converted into the gas, and then turbine runs, and with the turbine, our alternator is coupled, and then it converts the energy into the electrical. So in this process, huge amount of energy is wasted. So, but But when it is injected into the grid, when it is generated, even from there, from the sending point up to the point of utilization, again, efficiency is better because now it has been converted into electrical form, and electrical energy is best form of energy from the not only utilization point of view, from the not only from the use point of view, but also from the point of view of wheeling from one point to other point. It can be wheeled with minimum losses. Best way from one point to other point, huge, large distances, thousands of kilometers. It can go. So this energy, but in the wires, though it is, elevated to very high voltage. So when voltage is increased, current is decreased, and I-square losses are decreased. But when voltage is decreased, then another type of losses, corona losses, annihilation of the air around it, another type of problem. So, but we designed the system with a minimal loss point of view, but even then, large losses. So, all this to reach 1 unit of electricity, one additional unit, we can see how much energy, how much, because every unit when added, we need to add the infrastructure also. We need to add the transmission line also. So incremental increase in the energy. So if you can save 1 unit of energy, it is much more than 1 unit of electricity generated. So energy conservation, that is why it is very important, very, very important aspect. It is anyway not less than energy efficiency from the importance point of view. Another quote that I like is, the greenest watt is the one that does not have to be produced. And that is what I was talking about. Save the energy. Save the energy, even it is better than renewable energy. So my conclusion is, energy efficiency is not a costly affair. Use the energy efficiently. Even you have to pay more for the star-rated instruments, buy that instrument. You will see that it will give you much more return. It will save that amount of energy. Like if you are buying AC, when you buy 5-star AC, as compared to single to 5-star, let us say 1.5 ton AC you are buying, you are saving, 700 to 800 watts. 700 to 800 watts. Where star is non-star or single-star AC, 1.5 tons, it will be 1700, 1800 watts. This your 5-star AC will be in the range of 1000 watts. 1000 watts, 1100 watts, like this. 1150. It varies from company to company. Actually, it depends on energy efficiency ratio. ER, energy efficiency ratio. It is written on the appliances. It is written on the this compressor on the compressor and the inner unit also. So you can see. You can verify first from the manual. You can ask, I need the better, most efficient AC. Maybe incremental cost, you will find that you have to pay a little, let us say 10,000, 20,000 more. Believe me, calculate it yourself. If you have to run it for 10 hours every day, within 2 to 3 years, it will be paid back. So don't go for single star rated PC. Buy the highest rated one. Will save lot of energy and will have a better experience. So energy efficiency is not a costly affair. Energy conservation is the best way of keeping our planet green. And last note point is that continuous research and innovation makes it further a better a choice. Thank you very much. Thanks a lot. Any question? Any question to anyone? Hello? Hello?
हेलो जी सर. हाँ सर, थैंक यू सर. मुकुल,
Yes. Yes.
हेलो.
Anyone have any
Yeah.
query, please ask.
मुकुल प्लीज टेक अप. हाँ.
Okay, sir. If anyone has any query, please unmute yourself and ask any question that you have from the sir.
Uh, Let me first. Yeah. Now I'm visible, I think.
Yes, sir.
Yeah. So, any question to anyone? Energy efficiency, that is very important aspect. That is my favorite topic. Always we should strive to save the maximum. Even I tell many times to my students, especially when in the fourth lecture, after fourth lecture, they are going out, I request all of them that giving the importance, showing the importance of saving that energy, I request them to switch off all the appliances. Light and fan without waiting for tune. We know that some tunes will be deputed and he will switch it off. But he will come probably after 5 p.m., sometimes 6 or 7 p.m. And by that time, if in the second half there is no class, then you can imagine how much energy will be wasted. So every day, scholars can save a lot of energy silently if they do not need any recognition. And I think such kind of works do not need recognition. Satisfaction itself is the biggest return. Self-satisfaction of saving the energy, making the environment cleaner and better a place to live. That is what the energy efficiency and conservation is all about. I hope you will be agreeing with me.
Thank you very much, sir, for your kind
If there is
words.
no question, thank you very much. Oh,
हाँ सर सर.
hello.
Dear participants, if you are having any question or
Thank
any
you.
doubt, hello
Thank you very
doctor
much.
sir.
Yeah, doctor.
Thank you sir, thank you for coming us. Thank you for joining
Sir,
us,
I
sir.
can listen.
Thank you so much, sir, for delivering such a wonderful talk. Thank you, sir.
Thank you, Tiwari sir. Welcome and thank you so much
Thank
for
you. Thank
delivering
you
your
for
talk in
providing
Gautam
me
Buddha
a very
University.
good opportunity. Yeah. Thank you, sir.
Thank
Thank
you,
you.
sir. Thank you. So,
All my
dear,
pleasure.
thank you, sir. Thank you. So, dear participants, so next talk is basically by Professor Ashish Kumar Singh. He will join us at 4 p.m. So, wait for just 5 minutes, and we will continue our talk. Okay. So, we are waiting for the sir. Sir will shortly join us. Talk will start at 4 p.m. Okay. So, just wait for it.
Okay, sir.
So, dear participants, sir will join us shortly. So, sir is trying to connect us. So, shortly we are having with us. So, sir had joined. Mukul,
Okay, sir. Okay, sir.
Insha, Mukul,
Yes, sir.
Insha. Hello, Insha.
Yes, sir. Yes, sir.
Yes, please.
A very good afternoon from Insha Zera. It gives me immense pleasure to represent my department, SOE. I welcome you all to this prestigious program on various aspects of energy under the theme Emerging Trends in Power and Energy System, organized by Gautam Buddha University. The conveners for this workshop are Dr. Omveer Singh and Dr. M.A. Ansari. Today's guest faculty is well-known personality, Sri Ashish Kumar Singh. Sri Ashish Kumar Singh is Professor in Electrical Engineering Department of Motilal Nehru National Institute of Technology, Allahabad. He did his graduation in electrical engineering from HBTI Kanpur in 1991, post graduation from REC Kurukshetra in 1994, and obtained a PhD degree from IIT Roorkee in 2007. Since 1995, he has been an academic staff of MNIT, Allahabad, and India. He is a senior member
This
of
call is now being recorded.
he is a senior member of IEEE and life member of Indian Society for Technical Education (IST). His research interests includes power quality, power system planning, smart metering, power system operation and control, AI application in power system, energy management, and smart grid, along with extension teaching in various areas of electrical engineering, such as power system,
Hello.
quality, renewable and electrical.
Hello.
Hello?
Am I audible?
Yes, sir.
May I request you that you please leave the remaining part for me of the introduction?
Yes, sir, sure.
I'm sorry for making this a request, but will you allow me for this?
No, sir. Go ahead.
Okay, thank you. So do not, there is no need to read this all. Let me first verify myself that I am Ashish Kumar Singh. I think I'm a visible and audible both. So Dr. Omir Singh can verify that it is Ashish Kumar Singh is speaking only. So
Yes.
this is a regular thing which we do during the examinations also, right? So we just verify the candidate and in this case the speaker. Okay. So thank you, Dr. Omvi.
Welcome, sir. Welcome.
For calling me again. I remember that I visited your campus in 2019, sometime before around February or March. I do not
March, sir.
remember.
March.
And I'm thankful again that you remembered me, but and congratulations to the department that you people have organized such a wonderful course, which has some very international speakers, and I'm seeing some very good names in the very good researchers in this in the list of these attendees also. So I appreciate the efforts made in organizing this event, and I have been given this topic of this for this course, emerging trend in power and energy systems. Let me start presenting my slide. Yes. Yes. So this is the topic. Slides are visible. Hello.
Yes, sir. Yes, sir. Visual.
Okay. So this is the topic given by the organizers. I think there is certain change, some specific change has been made in the topic. I was given the topics on the insights of power systems, but just to match it more with the topic, I have modified a bit insights and emerging trends of power system. There I will like to share with you some present challenges what we are facing right now. I will start right from the beginning, original shape of the power system with which it was designed. Then what are the challenges which we are facing right now? And definitely some future trends also I would like to discuss, which are either under process or we are going to start thinking about them, so that this emerging things just to make that system sustainable. So that is more important. Omirji, will you please allow me to this off my this camera, because this bandwidth issues.
Yes, sure, sir. Sure. Please, sir. Please.
So
Please, sir.
this will add my comfort basically.
Yes, sir.
Yes. So, so this is about the old power system from where we have started some several decades ago, and this story goes in the early years of 1880s and 1890s, right? And since then, this power system has been continuously evolved since the beginning of their deployment during the late period of this industrial revolution. Because this focus on this electricity was made after this industrial revolution came. So right from it started from the first commercial power plant that was started in Pearl Street by Thomas Alva Edison in 1887, if I do remember correctly. But that was the first business event for this electricity purpose, you can say. And the limitation was that, yeah, you can say as a special feature of that event was, it was a DC generator to power New York City, and that a very limited length of 1 square mile. That was 1 square mile, and in some records it is available that it was 11 kilometer long. So you can just imagine that it was just a strip of a city of New York City in that year, which was arranged for this this distribution of electricity, specifically DC it was. But what has happened right from that beginning, today it has become a sprawling network of power lines across land and sea both, connecting often distant power plants, which are generating, most of them are generating AC, and that also on some very specific 11 kilovolt. If we talk about the conventional thermal generators or conventional hydroelectric plant, so this is a specific specification of generation is there, and it is reaching to numerous points of use to us, to all the consumers. So significant progress has been made in power system about technology, efficiency, quality, safety, and reliability. So we are very, if we mention that many several decades ago, it started from a low power generator and serving in a limited area to highly interconnected networks and serving multiple countries, or rather you can say continents, because in India we have an example of this transmission and generation. Generation is taking place in Bhutan, and we are using it, this electricity in India. So this is a limited part of Asia, you can say. But if you see the interconnection of the Europe, you can find it that the whole Europe is connected, right from the Denmark and Germany, Finland. They all are having a connected grid, and there is a website called Eurogrid. You can check it there. Like every time the input power, intake of electricity and generation given to our country, that all is visible variably on that table in the on the screen. So. So you can say this electrical power system, this is one of the man-made largest power scale system, comprising of huge number of components. You can say some electrical components are also there, some mechanical components also there. So this is from low power electric appliances into which it is feeding. So this has reached to very high power giant turbo generators. If we talk about the thermal power plants, so they have right now they have the single plant is having a capacity of some 2,000 megawatt thermal power plants are existing right now. We started right from very 11 this initial generation in some limited kilovolts, around 13 or 14 kilovolt. That DC was, which was served at New York City, Pearl Street. But right now we are having a transmission capability voltage level of 800 kilovolt DC that we call ultra high voltage DC, or we have some PHVAC lines up to 735 kilovolt in case of AC. In Indian scenario, right now we are having a test bed facility of 1200 kilovolt just for the manufacturers or equipment manufacturers for their testing purposes. And it is this 1200 kilovolt facility, testing facility, is available near Bina in Madhya Pradesh. That is a government facility right now. But still in India, the highest voltage which is available for commercial transmission and uses, that is 800 volt DC and 735 kilovolt AC. And This is the transmission line capacity basically. Various transmission lines which are capable of 730 kilovolt voltage level, but they are being fed with 400 kilovolt only just because of some limitations not recorded anywhere. So these electric power systems can be broadly classified by mechanical equipment and electrical equipment. And this particular paper of this 2011, this very clearly justifies what is mechanical here in this power system and what is electrical in this power system. On the left hand side, you can, in this diagram, is it my screens, the slides are visible or not? Hello?
Yes, sir. Yes, sir.
Okay, thank you. So, so this is left side. It is mechanical part, which you can say this fuel source, pressure control, furnace and boiler, speed control and turbine. So these controls are applied to the mechanical parts. And in right hand side, you can see the generator is having this voltage control, and this network is having some network controls for voltage level, current level, losses, etc., whatever that is. And loads, they are having specific demand which is to be met by the supply that is being controlled. And this all is being monitored by a block given in the bottom of this diagram, that energy control centers, they monitor all this power system to what is happening and where it is happening and where a necessary action is required. So as electrical components, we can say the control system and communication infrastructure, this is available as electrical component, and this tap changing under load transformers and massive numbers of rotating machines as load. Most of them are tidal, this three-phase induction motor. They are mechanical components available. Other than this, some other motors, induction motors, this synchronous motor, and you know all different types of special motors, they are also the part of this power system. But this power system, you know, as we discussed about the control, we can say this control is really a difficult aspect of this power system, because the dynamics associated of different blocks we have seen in the last page, that dynamics is basically this varies in the time response. It has a variable time response right from the microseconds to hours, which are happening for the events which are happening within the power system. So right on this diagram, you can say on the left hand side, this is going to 10 to power minus 7 second. And on the right hand side, this is going to 10 to power 7 second, 10 to power plus 7 seconds. Here you can see that the lightning propagation that goes on the most left side, and this boiler and long-term dynamics, they are coming as a right hand side. And similarly, some planning events, they also take some years in this case of power system before they are made available to the for use in power system. Right now, the scenario is actually different. So I have been asked to discuss some trends about this today. So what are the trends? They are difficult to generalize, because there are in the system there are some system made constraints, such as efficiency of the system that depends on the losses taking part in the system. But here the scenario has totally changed with this upcoming constraints on this global energy security and environmental pollution problems. They have been given as a prominent concern. They have been taken as a prominent concerns today for this today's power system. So we have, as a power system engineer, we are expected to provide clean, reliable, resilient, and affordable power to everyone. Right? I think you are aware with these terms. What is clean, what is reliable, what is resilient, and what is affordable, right? So this all is related to this environmental pollution problem. So just to handle them, these few terms of these, they are related to this, so that electricity produced must be economical, so that it is affordable to everyone. It must be resilient, so that it is available to its customers, reliably available, with good specifications, with good power quality. It is also assumed that this cleaner power system will lead to no pollutions. They will lead to no climate change, or they can stop the continuously increasing climate change hazards. So definitely this is going to improve public health, and this this is going to help us in combating the climate changes. So what is happening right now? This topic has been very wisely chosen for this FDP, that there are major transformations are taking place in power system right now, and they are not suddenly happening. Basically, they are being invited to the power system. These transformations are being done with a specific purpose, and they are being taken as a strategic imperative to achieve the goals specified by the humankind. So what are the goals? So today the challenges of power system largely arise from climate crisis and more efficient, reliable use of existing resources and infrastructure, right? So resources were already defined in two different categories. One is the conventional source that we also called fossil fuel based resources, and second they are non-conventional sources. These non-conventional sources are promoted right now in a new scenario because they are responsible for giving us the clean energy, because this energy is basically a result of carbon free production of or carbon free transformation of energy, which we are going to use as electricity. The history of these changes that goes back to the Paris Agreement, and there it was expected from all parties to ensure that the concern was, the point of discussion was, is continuously increasing global average temperature that shall not increase much, and that shall be some within some limit. And the time and this level of that temperature was considered this pre-industrial level. So it was targeted that this shall remain below the 2 degrees centigrade threshold from the pre-industrial levels. Later, in additional efforts, it was also targeted in some later stage. It will be better if it is not exceeding beyond 1.5 degrees centigrade. Okay, so right now we are fighting just to limit these global temperature increase, global average temperature increase, that shall not exceed 1.5 degrees centigrade. So all the stakeholders or all the members of this who were countries who participated in Paris Agreement, they became the stakeholder to undertake rapid actions for reducing these greenhouse gases emissions, because these gas emissions, GHG gas emissions, were responsible for increase in the global temperature. So immediately these European countries or some other countries, they have started taking their effort, they have started their measures they have taken. And for an example, you can say that European Commission proposed a 40% cut in the greenhouse gas emissions relative to 1990 levels by 2030. So they targeted they will go back, they will go beyond 1990 levels, and so that's why they are very much focused on this renewable energy conversion based electricity generation, and that their target, they are targeting that by 2050 their all electricity generation will be renewable energy based. Yes, it is possible, but it also has some its own challenges. That challenges is to be taken care by the power system engineers, because this control right now, the control is very much you cannot say it is difficult. Basically, recently we have seen that 9-minute power light call by our honorable Prime Minister. We did that, and we shall be very proud of that, being a power system engineer. Yes, our power system engineer community handled that situation very efficiently and became a pride of for right matter of pride for all our countrymen. Yes, they participated in a national call by our honorable Prime Minister. So such things sometimes they seem to be difficult, but right now the controls and the control mechanisms, such mechanisms are available by applying theoretical principles, or by applying this heuristic knowledge of the operators. They all come together to create some wonderful results. and it happened in that case. So we come back to this Paris Agreement policies. Such policies have direct consequences on power systems, as electric generation is responsible for a 42% level of this global emissions. At 2013 was done by the electric generation, and the remaining was for transport, from cooking, etc. etc. And number of reasons were there, but 42% global emissions were being done for electricity generation. This particular data was reported by the International Energy Agency report in 2015, and later replacing these technologies with more environment friendly and sustainable ones without compromising the range and quality of services. Yes, this range of quality of services is very important, because in case of conventional power generation, we have reached to a sufficient level where we can produce electricity with a good quality, and we are capable of providing a good service of electricity. But when we are trying to change our generation of electricity from conventional to non-conventional, or we are trying to convert it from fossil fuel based to this renewable energy based systems, then definitely it is possible that we are having a this is expected that there may be some compromise with these parameters, but definitely the challenge is that there shall not be no compromise with those levels of quality to which we have already to whom we have already reached. So this integration of a significant amount of RES technologies, and the challenge is this RES technologies, they are mostly non-dispatchable, right? Number two, they have this limited or no inertia, such as wind turbine generators and PV panels. So this is also a challenge when we are going from this synchronous generator-based power system to this RES technology-based electricity generation. But solution is, it is already proposed and established that by adoption of these energy storage solutions, we can make these RES-based generation from non-dispatchable to dispatchable. Yes, we can do it, and it is established technology right now across the globe, and major investments are being done for this particular requirement. And this expansion of transmission and distribution networks is also required, because it is expected that this RES technologies, using these RES technologies, we may need a different set of transmission infrastructure, because this renewable energy based generation is going to take place some specific areas where the availability of these resources are in abundance, just as these wind turbines can only be placed in some specific locations, not everywhere. Similarly, the photovoltaic panels, they can be placed anywhere, but definitely if they are being placed at some those areas where this availability of sun is across the day and across the year, then definitely they are going to be a good resource, and this variation in generation that can be that is not available. So these are some limitations. So this is already a difficult task by this conversion or this transformation of electrical power system, which is going to be further more challenging by this additional demand predicted. It is already predicted that our energy demand is going to increase by some 40 to 50% in next by this next 2035. You can say, in some cases it has been predicted by 2050. There is a report of 2011 where this prediction of this uh, I do not remember exactly right now, but that particular report, I was just reading that yesterday. That particular report has clearly mentioned the ratio that has considered three different scenarios for large penetration, medium penetration, and small penetration. And this efficiency they have also considered. So in that way, they have considered that this some 54% consumption is going to be increased. And in some other report, this is assumed that by 2050 the population is going to be increased. This was predicted some 10 years back actually. So this population is also going to be increased by 37%. So if we consider comprehensively these two things, so this totally comes around that by 2050 this electricity consumption may be double, right? And some other report which I'm also presenting over here as a data, that in 2016 the Germany consumption was 570 terawatt hour, and this it is expected to reach by 2050 to double, more than double, because they are expecting that there is going to be an increase of plus 400 to 800 terawatt hour increasing. This increase is going to take place because we are continuously reviewing our targets for this e-mobility especially, and also for heating. We are just to reduce this greenhouse gases. We are also targeting that this heating and transport, they all will be electricity based by 2050. So in that way, this consumption is going to be some more than double. So this is clearly shown here by data. So how to adopt these change in this power system? And this power system is continuously under transition. So change is how to adopt these changes. And second point is without compromising, right? It is just like the optimization problem which we solve. We have to reach this target, we have to achieve the result, but within these constraints, right? So you have this sort of problem there also. And the similar things is here also. If this change is required, but quality compromise shall not be there, right? So this is because our dependence on electricity has reached up to a level where we cannot compromise with that. So definitely we will keep on we will continuously say yes, this quality of supply, because this right now this power quality is also a subject of electrical engineering. This is the area of research in electrical engineering, which was 20 years back, it was not there, right? So this power quality is a major thing, reliability of power is a major thing. So these things cannot be compromised. Next comes the safety and reliability standards, right? So this safety and reliability standards we have achieved with conventional power system, right? Where the demand of electricity is continuously growing, right? But it is expected that in next few years, this power system portfolio is having a target of this 100% RE generation. In our country also, our Honorable Prime Minister has given us some targets for generation of solar power. And definitely, in some other lecture, I've last time at GBU, I've told these things that I presented that through graphs. What are the targets and how much we have achieved and how efficiently we are performing in the global scenario. So it was presented last time. I do remember that. So as Europe has a target of reaching the 100% RES by 2050, we have not fixed this target for this 100% RES implementation. But definitely we are increasing step by step. We are having some very large targets and we are continuously trying to reach those targets. So definitely these targets for a European scenario, these targets for some global scenario in some other countries, it is expected that a big change is going to come in the power system structure, you can say, in terms of power system generators, in terms of power system transmission lines, in terms of distribution system, right? So this all change is going to take place. And definitely this change is going to take place between this 2030 and 2050. By between these period, some countries will be very close to reaching their goals of 100%, and some countries will be very close to the given specific goals which are not 100%. So definitely we must see that how these changes are going to happen. Since electricity demand is expected to grow in many countries, so definitely by this generation increase, generation increment is not, it shall not be proportional to the population or the requirement of electricity, because this efficiency of different appliances, that plays a very important role, or efficiency of the customer or power consumption, schedule of the power consumption, they play a major role in this in defining the electricity demand of the network, right? So electricity demand is expected to grow in countries for different reasons. Yes, because I was having lesser number of loads in my home yesterday, but today I'm having some more number of equipment for my use. So definitely some this utilities, they have also come with major schemes, right? And they are having the positive role in addressing these challenges. Some this suppose there is a one technique, not suppose, let me introduce that there is one technique, demand side management, which is aggressively being used by the foreign distribution companies to this flatten their load curve, right? So, because we all know that there are some specific times across the day, or across the week, or across the year, when there are demands are very high, right? And there are certain times when generation is there, but the consumption is not there. So there are several peaks and valleys in the load curve, right? So just to balance this load curve, utilities use this DSM, demand side management, and this particular table presented over here, that this DSM is benefited for customers, for utilities, and as well as society, all stakeholders. So how this is for benefited for customers? Because this customer satisfied demand for electricity, it adjusts its time of consumption. Then when this demand, no extra demand is to be fed by the utility, then definitely the cost is also reduced. Then definitely he is going to get better service, right? And when he feels that this electricity is available as per his requirement, so he treats the electricity as a reliable source, and definitely it adds that confidence in his life, and his lifestyle and productivity is improved. So this DSM benefit for utility is, it goes for a lower cost of service. Definitely yes. It goes for improved efficiency and flexibility of the power system. We have defined this flexibility in some later slide. And reduce capital needs. Yes, no more electricity, extra electricity is to be generated. So reduce capital needs because customer is ready to follow this demand side management. And in this way, the better relationship is there between the customer and the utility. So customer service is also improved. And who is the hidden beneficiary mostly? Society. Society is the hidden beneficiary, which is having a long-term impact of if this DSM is happening or this DSM is not happening. Because the resources which are going to be wasted if DSM is not there, so definitely this is the loss of the society, this is loss of the country. So the societal benefits are, the resources are conserved, environmental impacts are reduced. So definitely this leads to environment protection and maximize customer welfare in terms of protection, in terms of climate change, and in terms of better service and a happy customer. So this is the DSM advantage, and this was already started very early, but that was nowhere to related with this Paris Agreement. Actually, DSM or Paris Agreement, they do not have any relation. This DSM is a technique which was implemented by the utilities in very early years for the benefit for this saving of resources, and just to flatten their curve, load curve. So this was a different motive, but yes, presently this is having some impact. So DSM has been traditionally concerned with promoting the efficient use of existing power system infrastructure. It is making consumers aware of the states, that is the status of the grid, regarding supply availability, how much supply we have. There are the provisions of penalty if they are burdening the system. So this way, a teaching has been given to the consumer
Yes, if you are in a position to shift your load when there is an extra burden on grid, and you can shift your load to that time when there is a valley in the load curve, then it means if you participate in such programs, these programs are called as demand response programs. So then there is a reward for this participation, and in this by this because what was happening, this was time-based tariff they were using. So this particular when this burdening of grid was there, electricity was costly, and when this valley was there or demand response program were participating, so at that time definitely the consumer was consuming the electricity when it was cheaper. So, thus motivating consumers for a more rational use of available resources. This was an outcome of DSM and other programs which were initiated by the utility companies. So these goals are achievable with the developments in definitely. So when whatever this DSM has been implemented or DR has been demand response has been implemented, so definitely there was a need of continuous communication between all stakeholders, means generators, consumers, or these demand side operators, or distribution system operators, transmission system operators. So these all these stakeholders, they must be in communication, in a real time communication, right? So what happened, a bidirectional communication was started between the grid operators and end users. And why this ICT or this communication technology was implemented, the purpose was to communicate about dynamic electricity prices, which were changing as per the load on the load curve, the availability of local generation resources, yes, the RES based generation, which was more at some specific times of the day, and it was not sufficient at some other specific times of the day. And this all was fixed with some forecasting techniques, and it was communicated to them in advance. And then the request, they were about to be communicated about the request of the load's flexibility. The flexibility of the load, yes, if any additional load or any decrement in load, that must not change the stability of the grid. That was also possible with this communication. Then facilitating load scheduling using this DSM or DR, this facilitation was also there. And this integration of DG was also to be communicated. Yes, this particular DG will be in use or this will be out of use during this particular time. So accordingly, all these parameters, they were the parameters who were defining the service quality of the grid, more reliability of the grid, and definitely the cost per unit to the customer, to the consumer. So what are the pros of these things, of these technologies? Because these technologies allow for reduction of peak demand. So definitely the quality and cost both are saved, but they also add to the provision of additional services, ancillary services, which are required to maintain or improve quality of service standards in power systems. And what were the cons for these? They were collection of too much data from customers' smart meters. Yes, every time a smart meter is utilizing per instant consumption, it was every sample consumption was there. So it was metering everything. So it was definitely giving a clear information about during this time consumer was most active, during this time consumer was least active, and this was the time. So anybody may assess by seeing this load curve what is happening there. So anybody can assess what is the daily pattern of the life of this user. So in US, started from US, where they started raising concern about the privacy, about the potential intrusions, and resiliency to communication failures. So these were the concerns. They are they are required to be addressed, but sometimes yes, electricity meter, smart meter that stores all the data, and that data of the consumers, they are used by these companies in a very with proper decoding, or you can say that it is not easy to get by the seeing that coded number. You cannot see, yes, this is the data of this particular house number. But this was a concern which is a great priority. And in this particular time, the data is the most important thing that is to be prevented from loss. Now, what started happening when these consumers, they became prosumers. You know the prosumers means if I am a consumer in the system, it means I am a passive user of electricity. I am getting electricity from the power corporation and I am using it. But as soon as I install a solar PV system of 1 kilowatt or 2 kilowatt at my rooftop, or I install a wind turbine in my backyard, and I connect all this to my system for this power system of my house, so I become a prosumer. It means now I'm in dual roles, active and passive both. Passive means I may use electricity which I'm getting from the grid or utility, or I may satisfy my requirement of electricity with my internal generation. So when you move one step ahead, the prosumers sometimes they have more generation than their consumption. So at that time they supply this extra power to the utility also, right? And there are the provisions of this net metering which are available there, and this net metering is mode by which this billing of all the customers who are the prosumers, they are that is adjusted in their monthly bill. But recently I have read a new term that is called prosumers, prosumagers, right? So this is a really interesting term which I found. This particular term is used for those prosumers who are having a battery storage option with them, right? So definitely this battery option, adding these battery options, make these prosumers a source of dispatchable energy they can provide, and that adds in such a way now their access power is not dependent on the instant of its generation, right? Now this prosumer has a flexibility to feed it in the grid as per his requirement. When he will see that this particular at this instant the electricity is costly, yes, I will sell it. If it is not costly, I will not sell it, right? So definitely these are the options which are adding day by day. Yes, they are having their own advantages, they are having their own disadvantages. Some 2 years back there was a paper regarding this microgrid. That particularly appreciated all these developments happening, but in the last, they have written that this utilities in the Europe, they are not interested in promoting this net metering facility, because they are not interested that prosumers or prosumers, they shall participate in selling their electricity back to the system, because the system is, because in that case they are not clear how much electricity is going to enter at what time, because these prosumers, they are not doing any agreement for this electricity feeding. So it is not easy for the distribution companies to manage the power flow in the grid. So there are certain views in public domain. Yes, they are not interested. Utilities are not interested in this buyback of electricity shall take place. So definitely they are working more in the area of microgrids, where this they are consuming the electricity either in the islanded mode just to make their more sustainable in form of electricity, or they are right now they are promoting this as a peer-to-peer in a microgrid network, microgrid community, you can say, right? So this is a very new concept, not very new, you can say this is more than 1.5 years or 2 years old. Several papers are available where this clustering of microgrids is there, right? So you may sometimes you may find it as clustering of microgrid, or sometimes you may feed it as a networked microgrid, where several microgrids are networked to make a more dispatchable, a bigger dispatchable source of electricity. And in this way, when they are having a sufficient surplus of electricity to trade, then they through aggregator they participate in this market also. Or sometimes when they feel that they are not having the sufficient surplus of energy, then they do not trade with the market. They simply do a peer-to-peer trading within the microgrid. So these are the two different scenarios which are happening if there is recent research in this microgrid area. Yes, this safety and environmental standards have also improved over time, and the concerns over human health due to pollution and other hazards, they are also a challenge for power system engineers. And in some ways, we can say the power system, this power system scenario, just because this generation technology has changed a lot. So right now, the blame on the power system, or basically from these thermal power stations, for the pollution, that is diminishing day by day, because there is nothing we have heard since last many years. Any country or anywhere in India, we are going to install some this new thermal power station. But right now, there is a big discussion on this. Are we not doing mistake? Yes or no? If we are not planning for new thermal power stations and we are planning towards only RES, because such type of one experiment was made few years back in Tamil Nadu. What happened? Tamil Nadu, they found that there is a huge resource of wind, right? So they installed these wind turbines there. But we all know that these all natural resources, they depend on some natural reasons also. So whenever there is a scarcity, and at that time there was no provision of storage was made, because this is right now when the storage is getting cheaper day by day. But in earlier days, it was not that cheaper. So that particular project in Tamil Nadu was not having any provisions for this battery storage. So what happened? This sometimes they were not having this sufficient thermal generation. So they had to face some huge scarcity of electricity when this wind was not available to move the blades. Definitely, this was going to happen if this was not planned efficiently. So what happened? There is a specific line from Raigad to this. There is a special line of 800 volt HVDC right now is under. I do not remember the name. You can find it there. This is one of the largest transmission lines of India, and with the highest voltage available, that is 800 volt UHVDC line, and this is supposed to feed this thermal power from this Odisha to near Raigad, yeah, Rajgarh, that is the place, to that place Kolar near this Bangalore, right? And there is some more one more place is there to which they are going to connect with this UHVDC line for feeding the electricity to the southmost part of the country from the middle part of the country, where this thermal is in abundance. So such things, they are still a concern. If suppose we are going to move towards this 100% RES, then from where this extra surplus, whenever the extra need will be there, or there will be a negative generation or less generation, then how these things, demand and supply, they will match. This is definitely a big matter of concern. So let me tell you what I am attempting to describe with all this background which I have stated till now. These are the 11 blocks which I am presenting over here. So these are, I have identified them as a major 11 challenges for future power systems. And if we start right from here and we will move in this clockwise direction, so first one is the connection of small distributed energy resources to distribution grid. Yes, this is happening. This is taking momentum, this is getting momentum, and it is expected, as we discussed earlier, that this is going to be 100% RES based also. In some countries, they have targeted to be by 2050. Then here comes the large volume of data. So let me tell you very first, I forgot that thing to tell you in the beginning that what is the major challenge or what is the driver for these changes, right? So we can summarize the basic drivers for these changes. They may be summarized as we are trying following three changes to bring in our power system. The very first thing is decarbonization, right? It means whatever CO2 is being generated, we are trying to stop that. That is decarbonization. Second is we are trying to make our grid, that attempt is digitalization. By digitalization, we are trying to make our grid more automated. So we are trying to add automation at every level of the grid, right from the generation to the point of consumption. And we are using sensors at generation. We are using SCADA at the level of this transmission and distribution. We are using PMUs at the level of transmission. Though these are being costlier devices, though they are costly devices, but recently there are some new research papers are available, and they are saying it as DPMUs. They are researching on DPMUs for distribution systems with some special arrangements to reduce their cost, right? And similarly, we are using this distribution automation in distribution systems. We are using smart meters at the consumer premises, etc., etc. And at this load level, we are using this Internet of Things. IoT-based devices are there, and right now this market is full with some Alexa-based devices where you can say to Alexa, Alexa, open the bulb, Alexa, open the fan, or something like that. You can give your instruction on the mobile phone or through remote from some remote point. And the third point is decentralization. So the three Ds, they are the basic driver for these new challenges which are happening to power system. Decentralization means we are shifting right from the major bigger power generation to some smaller sources of electricity like PV at my home, wind turbine, my battery source, etc., etc. So this decarbonization, digitalization, and decentralization and digitalization, decarbonization, these three Ds you will find here in somehow this is available in all these blocks. So second is the large volume of data is generating from heterogeneous data sources. Means data is taking place generating at generation also, data is generating at the consumer premises also, data is generating at the load also, etc., etc. So this large volume of data and how to handle this data, because this data can be manipulated, this data can be misused, and this data can be a threat for the future threats because by reaching this data, these grids can be controlled and some electric terrorism, some sort of these things may happen. Recently, you have read that some major attempts have been made in last year for this cyber threat, cyber attacks took place in grid to power grid in Russia and in Uganda, right? So definitely, the if you are going to control the electricity of some network, It means you are in a position to control all the loads, all the services, all the devices, and definitely the life of all the users who are using that. This all will be in your control. Third point is the development of end user centric approach, right? This has been clarified as this end user, as a consumer, I am the end user. But what is happening right now, I have taken an additional role of prosumer also, right? So there must be a service, there must be a service available, a platform available where I can decide कि I will sell the electricity or I am going to purchase the electricity, or how much there must be a proper record of this, कि how much electricity is available in my store, and this thing shall be available to the service provider who is interested in purchasing my electricity. You can take it as an example, analogy example. I can say that similarly, you are having an app for everything in your mobile. You are having an app for your bank. You are having an app for your rail reservation. You are having an app for your air ticket reservation. Similarly, for this Ola and Uber, for this food order, you can try. You can select the food. You can select the vendor. You can select the time. Everything you can select, right? So you are the end user, and all these companies have developed these apps. Your interest, your choices, they shall be incorporated, and there shall be nothing which shall prevent, which you may not find something uninteresting, so that you may leave that app. Similarly, such type of service facility or service level that is going to be available with electricity consumer also in future. This is the challenge. Then comes the local energy transaction. Yes, this localization, this is similar to that local abhiyan that has been started recently in India by our leaders, that it says that we shall not being dependent upon this electricity from the grid. We shall try to generate our electricity in local. We shall share our electricity between our microgrid or our within our community, and we shall not depend on this external electricity which we are getting from the utility. There is a professor in IIT Bombay, Professor Chetan Singh Solanki. He has started one very unique abhiyan, you can say, that is Energy Swaraj. Energy Swaraj gives you an idea about this local energy consumption, right? They are developing, they are selling a business model to you using which you are totally independent of the grid, because they will give you an opportunity to generate the electricity according to your uses. So no grid connection in that case. So this here comes the local energy transaction, and definitely this is going to be possible in coming days, right? It is possible. It will be possible. Next comes the high uncertainty in net load consumption balances and flows. Yes, the load is going to be dynamic. Consumption of the electricity was dynamic right from the beginning, because it was not predictable what I am going to do with my electricity supply, how much electricity I am going to consume today. There was an average pattern, but some variation was always inevitable. Similarly, now what is happening, this load consumption was already uncertain, but right now in the new scenarios, generation is also going to be uncertain, right? So this uncertainty in this generation, uncertainty in the flow, bidirectional flow, you can say, right from the source to load and load to source, right? When I'm referring load here, I'm trying to communicate about the word prosumer, right? Who is generating and consuming both. So this flow of electricity, that is bidirectional right now. So this is adding more uncertainty, and the challenge is how to balance this consumption and power flows, and balance these power flows in this uncertain scenario. Yes, second point is need to rethink protection paradigm. This protection paradigms, what the protection methodologies in power system we have studied, this all were dependent on this flow of electric power in unidirectional. And similarly, this was already assumed right from the larger point to lower point on the higher voltage to the ground, this short circuit is going to be decided where it will happen and where it will impact, right? But what is happening right now, this power flow is bidirectional, right? It is current is flowing right from load to consumer and consumer to load in both directions. So it may be difficult to predict where the impact of this any short circuit fault is going to happen, right? Because all this takes place on the level of current or the short circuit capacity. Different parameters are there to define this location of fault or the impact of fault. So definitely new technology is required, or there is a need to update the infrastructure with new relay equipments of new technology. That infrastructure requirement and a major investment is required to improve the protection of the power system. Yes, the resilience of power system is also going to be a difficult parameter. Definitely the protection is going to be challenged with this new scenario. So definitely the faults are inevitable in this new scenario, and this resilience of this institutional system is also going to be under question. So this all is interrelated. To improve the resilience, this major investment in the power system and other this investment and the other arrangements, they may improve the resiliency in this case. The low overall inertia, yes, inertia is going to be zero, or that is going to be almost nil, because we are earlier we were using these thermal generators, turbine based generators, and right now we are either using the minimal inertia or zero inertia, because we are using the wind turbines and PV systems we are using. So this is a new challenge, and right now what we are doing for this, we are doing some power electronic based exercises for for generating synthetic inertia in the power system. Next challenge is energy storage systems and their integration. Yes, the cost of energy storage is getting cheaper day by day, and this is the new trend where every energy company is going to invest. That energy storage is going to be in two phases. We are going to have it with the system, and one is the energy storage available in the home with my this RES system, renewable energy system. And second is this our electric vehicles. They are also going to be a new source of electricity to add in the resiliency of the power system or to participate in electricity market. We will come to the later in the last circle. So these are the new storage things which are going to take place. So storage, you can say, storage is of two types. One is static storage. You can say these batteries in the home, or you can say moving storage. You can take these vehicles, electric vehicle batteries, at a as a moving storage, because our static storage, like batteries in our home, they charge and discharge at different times. When the electricity is cheaper, they will charge. When electricity is not cheaper, they will be used for fulfilling the requirement of home. But there is a facility available with these moving batteries. They may charge at some different time at different location, right? And they may discharge at some different time and different location to some other power network, right? So this is the flexibility of facility available with the electric vehicle, electric mobility, and in this way they are participating in the flexibility addition of the power system. So right now, this flexibility is the major change. Flexibility is the major thing on which some research is taking place. How these new participants, they are going to add in the flexibility of system. Then comes the power electronics. Yes, power electronics has played a tremendous role in the control of electricity, right? This it was very, otherwise it was very difficult for this any by any controller, or the controllers earlier or the devices earlier which were used for this power electricity control, they were also very big in sizes. But right now, with the thanks to power electronics, that everything which is used for this power system conversion, because all these things which we are using in our houses or for us our daily use, right from the mobile charger to computer, laptop, printer, television, everywhere within the system they are using DC only, right? So everywhere this converter of DC AC to DC is being used, and power electronics is also used for these smart transformers. You can say the smart transformers right now, they are coming into picture just for changing the voltage level, and they are more efficient also because the magnetic losses are not that much in that case. And definitely whenever there is a more improvement in the magnetic or semiconductor material, their efficiency is going to be improved. So that is the use, that is the advantage of using this power electronics. And definitely the power electronics is going to change in future. New improvements are going to take place, and how to incorporate or how to handle those changes, that is again going to be a more relevant challenge in future. Dr. Omveer, I think, is there any time or I shall stop?
You have, sir, 5 to 6 minutes time. Still you
Okay,
can.
okay. So in the later slides, I have these just explained all these things one by one. So I personally feel that there is no need to repeat these slides because it will not be possible to explain all these in next 5 6 minutes. So if I say keep using this diagram, if you have any question or any questions on the previous discussion, so that may take as a question for more clarification. Any questions?
Any question from the audience?
Uh, good evening, sir. I have one question.
Mm-hmm.
Sir, like we was talking about the bi-directional flow. So,
Mm-hmm.
what protection scheme do you prefer? Which one is efficient to avoid bi-directional flow faults, which we have?
So this is a very specific question,
Yes, sir.
right? And I personally feel that I am not a protection expert in the domain of that area. So I was simply asked to give a very specific introduction of very generalized introduction of this thing. So if you have some very specific question, such very specific question, you can write to me, right?
Okay, sir.
And we can exclusively discuss why to include everybody in such long discussion, because this discussion is going to be very long, right?
Yes, sir.
You can take my email ID. I will show it in the last slide. ashish@mnnit.ac.in. You may write, and definitely I will try my best to suffice your query.
Okay, sir.
Sir, one question is from Harshvardhan.
Yeah,
So,
please.
in your chat box, sir, according to some reports, it is stated that by 2040, data storage and management is going to contribute 14% of total world carbon emissions. Don't you think that while planning smart grids and all, we should consider this fact because these technologies will eventually increase data consumption and storage, and our main aim is to still to reduce carbon emission.
Yes. So how this carbon emission is going to, how this electricity is going to be responsible for this? Because in the energy sector, like specifically in electricity sector, we are planning to be by this 2035 or 40 or 50, by as a number you can say, we are going to be 100% dependent on the renewable energy resources, right? So this, when our system for generation is going to be 100% dependent upon renewable energy, then definitely this electrical power system is not going to be responsible for this carbon generation, carbon footprints, right? So as I told you that this electricity is generation is going to be this power system. It is expected that decarbonization, 100% decarbonization means 100% RES based generation, right? So I'm unable to understand how, from where this carbon footprints is going to generate by this data centers. Can you explain me? Harshvardhan? Harshvardhan?
Yes, sir. Sir, my question was that when we talk about concept of smart grids, sir,
Yes.
we will contribute to data consumption. Like I am a consumer and there is some supplier, and my daily usage data goes to it. It's the form of data, and this
Mhm.
data storage needs some plants where it eventually uses electricity and all to store it for better user experiences.
But let me tell you, in the future, this data is going to decide everything, right? What I have come to conclude from my all these whatever I have read in about this particular thing, what I have a conclusion that similar to this Ola and Uber, we are also going to have some companies who will do the business of electricity without having any power plant with them, right? So what is required there? In that case, you will have to do some business. You will have to purchase some service, and you will have to sell it to someone that service. Similarly, the Ola, Uber, and others they are doing with the app with the help of the app, right? Similarly, so what all that is dependent on data. You will have to identify the user. You will have to identify that user's pattern of consumption of electricity. You will have to accordingly you will design some very lucrative offer for that customer. Similarly, we have these offers for our mobile phones. If you are going to use this one, so you are going to have this thing free. If you are going to have this much use, you are going to have this much free. So what happens? Sometimes the persons who are very high user or heavy users of telephone, comparatively they are paying very less as per the income and expenditure. They are paying very less amount of telephone, even though they are using they are having very high uses. So this similarly, such plans may be available for the electricity users also in the future. What I have a belief, but designing for all these things, data is compulsory. Data of generation, data of transmission, data of generation and transmission will give you about the availability of electricity. On this particular moment, you have some excess generation to sell, right? If you are having electricity and it is not going to, you are not in a position to sell that, then what you will do? Because that electricity is of zero cost for anyone else if you are not going to consume that electricity or sell that electricity, right? So that's why these interfaces are being made available just to utilize, just to have plans in advance, right? So you just see this electricity is a very lucrative business nowadays. And in support of my statement, I will simply say, just inquire how many private companies are there in this business, right? And definitely if the private parties are doing the business of electricity, it clearly states that it's a profitable business, right? And data is the only thing which is supporting, because they are simply all these business on the basis of numbers only. Those numbers, either they are coming from the generation, or they are coming with the transmission, or they are coming from the consumption.
Uh, I think, sir. Thank you, sir. It's for such a good answer.
I think Harshvardhan is satisfied or not. That is a major thing.
Maybe, sir. He may contact to you, sir.
Definitely, Harshvardhan. If you are still not satisfied,
Yeah.
you are not feeling satisfied, you can call me. I can take number from Dr. Omvi, or you can write me on my email ashhesh@mnnit.ac.in. So I just want to communicate to everybody that you may write to on this email ID. I have this here in the last slide. Yes, I have written it. This is my email ID. Here you can find it. This you can write me on this email for your queries, and I assure you, I will try my best to reply those queries within 24 hours, right? Or you can also text me if you have anything.
Okay, sir.
Thank
Thank you very much, sir, for your informative session. and we are very grateful that you are here with us and delivered us the beautiful lecture on the topic. Thank you very much, sir. Now moving on to our next session,
So,
we
please
we
allow
have
me to thank Professor Ashish Kumar Singh.
जी बताइए.
Please, Insha.
Firstly, I am moved by the humble nature of Professor Ashish Kumar Singh, personality of his eminence belief in business. He has a tremendous contribution not only at national but at international level and does not require any introduction. But his contributions were briefly incorporated into an introductory note as a mark of respect and to act as a source of inspiration for the beginners like me. We are privileged to listen his valuable lecture, which is bound to guide us all in times ahead in our endeavors in the nature we have opted for. Thank you all, particularly Professor Ashish Kumar Singh, for his thought-provoking speech covering all aspects of the topic. Thank you, sir.
Thank you, Isha. Thank you for nice words.
Thank you, Ashish sir.
Thank you very much.
Thank you. And one welcome to Dr. A.K. Tripathi, sir.
now moving on to our session. I would like to invite respected Dr. A.K. Tripathi, sir. He is Director General, National Institute of Solar Energy, Government of India, and he is our chief guest in our STC. Thank you very much, sir. Please continue the session.
Uh, Dr. Tripathi, sir, are you listening, sir? अभी sir, just wait for a few seconds. Sir is joining us soon, within few seconds. So, so I am requesting to Dr. Nidhi ma'am, please say a few words. डॉक्टर निधि मैम, जब तक सर नहीं आते तब तक थोड़ा सा प्लीज. So, Mukul, can you take a feedback?
Yes. Until next event starts.
नहीं
Next
लाइन
session, sorry.
उमेश जी, निधि मैम है नहीं लाइन पे.
अच्छा लाइन पे कोई बात नहीं, तो जब तक ठीक है मैं।
वो जो एक हाँ दूसरी आईडी आ रही है वो अपने स्टूडेंट की है, मैडम की आईडी नहीं है वो।
अच्छा मैडम की नहीं है, ठीक ठीक ठीक, इट्स ओके, नो इश्यू। सो
Until
मुकुल,
the session starts, session resumes, I would like to ask a few anyone who would like to share the experience that they have incurred in past of our event in STC. Like we have our like Mr. Saurabh. If you would like to say something about the event,
मुकुल
you might
मुकुल
share.
सर है, सर है जॉइंट।
Okay, okay, okay.
वेलकम डॉक्टर त्रिपाठी सर। अर्चित पाठक। मुकुल
Yes, sir.
says few words about him।
Okay, okay, okay. Now,
Sir, may I
continuing to
speak?
our session, we have Dr. A.K. Tripathi, sir, who is Director General of National Institute of Solar Energy, Government of India. He is our chief guest in our STC program, short-term course on emerging trends in power and energy systems. We are very grateful and delightful that respected Dr. A.K. Tripathi, sir, has joined us and say a few words about the event and just provide his valuable knowledge to us. Thank you, sir. Sir, your mic is mute. Sir, please unmute yourself, then speak, please.
Yeah, can you listen to me now?
यस सर, वेलकम सर।
Yeah, I'm doing from mobile. Okay. So can you just let me know something about the event? Then I can speak.
मुकुल
Yes, sir. We have sir 12 sessions on the various topics. The
ओमी
first,
सर आप कवर कर दीजिए ये वाला
हाँ,
हिस्सा
यस
सर।
यस यस। एक्चुअली सर we have organized a 1 week short term course on emerging trends in electric power and energy systems. So this event is basically organized by Electric Power and Energy Club, and this is also a collaboration with the Design Club. So that is totally organized by Department of Electrical Engineering, Gautam Buddha University. So in this event, sir, more than 200 participants has participated in our event, and most of them are from outside of India. And in this event, basically 12 speakers have spoken from United States, Professor Nadmohan sir, and from the Bangladesh IEEE chairperson, and India's other institutions, faculties also spoken us with us. So they have basically enlightened us about the power system scenario and the energy systems also, sir. This is the basic theme of our event, sir.
sir, please
Hello.
unmute. Yes, sir.
Can you listen to me?
Yes, sir.
Yeah. Uh, Thank you very much for inviting me for this event. And today, in today's scenario, this sector is very important because nowadays you can see that a lot of solar installations and wind installations are taking place in the country. And the major issue of this, why this is uh, the major issue today, which is going to come and we are facing also, is the grid instability. So the electrical system and how to integrate with the solar or wind system, and then to maintain the grid stability. The combination of these three is very important. And I'm sure that the deliberations in this workshop must have addressed these issues, because these are very common issues nowadays, and a solution is being sought. because many large-scale power plants are being set up, and these plants are ranging from 1 megawatt to 1000 megawatt and 2500 megawatt capacity. But the frequent change in the solar field, which makes the grid little vulnerable, is the challenge. How to meet this challenge, either through some storage system or through some other technique, is very important. So I just want to wish all the participants and the faculty members who have really organized this workshop in a difficult time. But let us keep the interest alive, even without the physical presence being present towards each other. And I wish all the success for these deliberations. And I shall look forward towards the deliberations. If you can share with me, and wherever I can utilize it, send it to the ministry so that we can take advantage of this deliberations. Thank you very much.
Thank
I'm
you,
sure
sir.
that we'll interact more.
Thank you so much, sir, for coming with
Thank
us.
you.
Thank you so much, sir. Thank you, sir. So, Mukul, invite to participants for feedback.
Okay, sir. If any participant wishes to share, please share. Mr. Saurav Kumar, you can please share about the event that you have felt right now.
Yes, sir. Am I audible? I am Saurav.
Yes.
Yes, sir. Yes, Saurabh.
Okay. Thank you so much, sir. I am Saurav Rajput, Saurav Kumar Rajput, Assistant Professor from the Electrical Engineering Department of MITS Gwalior. First of all, I want to say thank you to all the organizing team of the STC program, because the STC was the wonderful. It was very wonderful in the thing which I observed. The first was the STC was wonderful because the speakers from the different institutes like MNIT Bhopal, Energy Institute Bangalore, NIT Patna, Jamia, MNIT Allahabad, Madan Mohan Malvi Institute. All the different speakers from the different platform were present on the same online platform, and I was able to get the knowledge of all these different speakers. And it was the STC was wonderful because the content was very much helpful in the development of the research ideas. Then I would like to say that the STC was wonderful on the part that in which it was organized, especially the timing. The timing was the timing which was selected by the organizing team. It was a wonderful because we all are the faculty members and we are taking the online classes in the morning sessions, and definitely in the afternoon session we were able to attend the STC program. So this was very helpful for all of us. Overall, I learned a lot from this STC program. And definitely, I would like to mention that in the end, the presence of the AK Tripathi sir from the NISC Gurgaon make the event more and more wonderful. Again, I would like to say thank you to the organizing team, Omveer sir, and other team members. Thank you so much.
Thank you, Saurabh. Thank you. And other participants, please.
Yeah. I'm Dr. Vatsava Naidu from Mathurpur Engineering College, Hyderabad. So in this pandemic situation, I attended so many STTPC and FDP also. This is the one of the best organization of FDP, STC, because of your eminent guest speakers, like very highly eminent, not only eminent, highly eminent guest speakers are incorporated in this STC. So I thank to all of the team members, organizers, and everybody. And only one small disappointment is Nedmohan sir discussion session will be that is
we will share the video of sir. Definitely, we will send you.
So I watch all the sessions, and this is a very, very excellent organization. Thank you very much.
Thank you, sir. Thank you. Anybody else?
Hello, sir. This is Mugdha Mishra here. I want to give my feedback regarding this FDP program. It was such a nice experience for all of us that this energy group provided such a platform in this COVID situation so that our speakers, not only from India, from all over the world, they came and they have shared their knowledge, their experiences with us. So I am really thankful to the GBU University, especially Professor Omkar sir. You have coordinated it so well with your
Omveer.
team, Omveer sir. And thank you, sir. Thank you so much.
Welcome, welcome, Uddhav, welcome. So, anybody else?
Hello.
So now we are going to. So, Dr. Ansari sir, please, please, thoda say few words at the end of this program. Dr. Ansari sir.
Yeah. Yes, Dr. Sahab, just some network issue. Thank you very much, Singh ji. Really, this experience of such a great gathering of 1 week short-term course on power system and energy, and we have a galaxy of the speakers, renowned speakers from various reputed institutes, mainly from Jamia, from MNIT Allahabad, from NIT Patna, from TCS, from industry. We have some speakers. So really, we had a great experience in this short-term course, and the organizing capabilities of Dr. Omir Singh and our research scholars Krishna Kumar and Mukul Singh have shown enthusiastic way to organize this workshop, short-term course. We have covered almost emerging trends of energy and power systems of the current scenario, in which the recent trends, what are the future scopes, what are the possible research trends, what are the possibilities in new research areas, that has been covered efficiently. And also we have invited two abroad speakers, one from Bangladesh, Professor Celia Shahnaz, and one professor from USA, who has given the scope and the some wage of the research grants and some research facilities provided by IEEE, funded by different organizations. And our Dean Professor P.K. Yadav sir has also given some tips how to get the research funds. And one of our speakers also given some research funding ideas. We are also very much thankful to the university, Honorable Professor, Honorable Vice Chancellor, Professor Bhagwati Prakash Sharma sir, our Dean Academics ma'am, and head of the department for extending their support to conduct this workshop, this short-term course. So thank you all participants. Hope you have definitely learned something from this short-term course, because there is no limit of the learning, and there is no time or no stage of learning. Anytime, anywhere you can learn if you are willing to do so. And I'm thankful to Dr. Omir Singh for cooperating and for organizing such a good short-term course. So thank you all. One thing I would like to add also, that all the participants will be getting the e-certificates. Today we conclude. Hopefully by Monday or Tuesday we will be emailing all of you your certificate. And the PPT shared by the various speakers will also be shared to you. Though some of the speakers were we could not get their PPT, but those who have given us, definitely we will provide it. So thank you so much. Thank you all for attending the workshop.
Thank you,
Thank you
Ansari
so
sir.
much.
Thank you, sir.
Now I hand over the Dr. Omi sir. Thank you,
So,
sir.
thank you, sir. Thank you, Ansari sir. So now I am seeing Dr. Naveen Kumar Sharma.
Yes, sir.
Are you say something?
Yes, sir. Yes, sir. Yes, sir.
Please, please.
Myself, Naveen Kumar Sharma, for Assistant Professor, Electrical Engineering Department in Punjab University. Sir, thank you for Electrical Engineering Department, Gautam Buddha University, Greater Noida, to give me great opportunity like this attend the STC program. Sir, I want to say about the speaker, there are the very good experience and good knowledge to provide in the direction of the emerging trend in the power and energy system with a lot of live example. Such a was a great experience to participate this SDC. And thank you, sir, especially to Dr. Omri sir and Dr. Ansari sir to organizing this the successful and well organizing SDC. Sir, thank you so much, sir. I will again next LDP. You want to always start the next series, so I will definitely join this LDP, sir. Thank you, sir.
Thank you, Naveen ji. Thank you. Thank you. So thanks to all participants. So now I am going to end our STC course, and now I am saying that we are sending your e-certificate within a week. So don't worry about it, the certificate. So now at the end of this event, I am thank you very much to for the Mukul and my scholar, basically my colleague, or you can say my student, Dr. Kishan Kumar Tyagi. So they have worked a lot
Thank you.
for this event. So now I am not taking much more time of you because we are having a constraint of time with us. So first of all, I thank to everyone for your gracious presence in our online 1 week short-term course, that is emerging trends in electric power and energy systems. And this is basically organized by the Electric Power and Energy Club, that our Department of Electrical Engineering. So in this program, basically we have incorporated 12 speakers are from United States, Bangladesh and India, beyond institutions like NITs and center universities. So they have enlightened us about the emerging trends and technologies like power system interconnection, power system planning, load forecasting, as a tool, and combating climate change result in resonance of electric power engineering, communication topologies for smart grid, electric network frequency of digital recordings, energy efficiency and conservation, solar water pumping system, building integrated solar photovoltaic system, pluralism in distribution system, and utilization of semiconductor in power system. And some other points we have also discussed in our STC program. I also like to thank our today's speaker, Professor Ashish Kumar Singh sir, Head of Electrical Engineering Department, MNIT Allahabad. He is also a chairperson of IEEE UP section. And also I am giving to thanks to Professor Prabhakar Tiwari sir. He is from Madan Mohan Malviya University of Technology, Gorakhpur. He is also secretary of IEEE UP section. They have given us technical and very good knowledgeable talks on energy efficiency and emerging trends in power systems. So I especially thanks to our Honorable Vice Chancellor sir, who has given this opportunity and supporting us for conducting this program. And additionally, I am giving my thanks to our chief guest, Dr. A.K. Tripathi sir, Director General, National Institute of Solar Energy, Ministry of New and Renewable Energy, Government of India. Number of projects are running under him. So I would like to thank to our Dean Acad ma'am, to Dr. Shwetanand ma'am, and our Dean School of Engineering, Professor P.K. Yadav sir, and also our Head of Electrical Engineering. They are supporting us for conduction of this program. And they are also motivating us for the future events, for the current events, they are also supporting us. So I am very much grateful to our BC sir for his encouragement to organize such type of academic activities. And I would like to utmost thank to dear participants for regularly attending this short-term course in this week from our country and also from the abroad like Sri Lanka, Bangladesh, Myanmar, and a number of countries. Participants have attended our program. So total 268 participants registered with us, and more than 100 participants have regularly attended our program via Google Meet or via YouTube channel. I am also thankful to my bottom of heart to Dr. M.A. Ansari ji, and additionally thanks to Dr. Kishan Tyagi and my research scholar Mukul Singh and my MTech student Insha Jahera. She is in Kashmir and she has supported on each and every day for their day and night hard work. I also thankful to my colleague and other students, those who are attending our program regularly. And I hope all of them may be benefited by our eminent speaker in this program. So we are planning for the future also as per your feedback. So now at the end of this program, I am requesting to all participants, please always attend such type of programs and enhance your knowledge and quality yourself in a power system domain. So again, thank you very much to all of you for making this STC successful. Thank you very much. Thank you. So thank you very much. So we are ending our session or basically
Thank
our.
you, Doctor.
Thank you, sir.
Can we have a group photo?
श्योर श्योर श्योर। तो आप लोग सभी ओपन कर अपने कैमराज थोड़ा
हाँ, एक वो कर लीजिए, एक ग्रुप ले, 2-3 पिक्चर ले लीजिए सब लोग। कैन वी हैव दी कैमरास?
कैमराज ऑन कर लीजिए आप लोग, अपने कैमरा को ओपन कर लीजिए आप, सो दैट वी कैन टेक द पिक्चर प्लीज। आकाश भाटी, थैंक यू थैंक यू। तो महमूद अब्दोली, आप आपका है, आप ओपन कर लीजिए। आकाश ओपन करो। एंड डॉक्टर किशन, ठीक है, ओके ओके, थैंक यू। सो आई एम टेकिंग अ क्लिक, जस्ट वेट फॉर फ्यू सेकेंड। So I am taking another photo. So these are the basically memories for us. Thank you, dear participant. Thank you, thank you, Dr. Saurmait Badi sir.
Thank you, thank you very much.
Thank you, sir.
Thank you.
We are ending our program. Thank you,
sir. Thank you very much.
Thank you.
To all the participants, please do go to our YouTube channel for live sessions. We have already streamed all the live sessions on YouTube. The link is provided in the chat box. I am provided it again. So you can just go to the channel. Do make sure if you watch the channel, like it, subscribe it, and share the channel to your colleagues. And for those who want to see the sessions again, you can just see the YouTube channel. It is being recorded on the YouTube channel live. Okay. Thank you, everyone.